Okay, now we're going to do some cross product. We're going to do 2.4. So this is all about practicing with the cross product. So question number 1, find the cross product of A and B. So let's do that. Okay, so to do the cross product, you're going to do a bunch of determinants. You're going to do I, J, and K. And we're going to set up our vector A, which is -2, 0, -3. And then a vector K, which is 2, -3, 4. Okay, and then we're going to take the cross product. So to do the cross product, we're first going to start with our I. So you're going to look at I, and it's going to blot out or kind of ignore these columns. What you're going to do is take the determinant of these numbers here. So the determinant is multiply these numbers and then subtract the product of these two numbers. So let's start with that. We're gonna blot out these numbers and focus on these numbers. 0 times 4 is 0, plus, or it's going to be subtracting, minus, this times this is positive 9. So for our first component, we're going to get negative 9. Okay, now we're going to follow and do the same thing with J. It's going to blot out this row and then these ones again. So we're going to focus on these four numbers. It's going to be this times this, which is -8. And I'm going to leave a gap here because there's something special about this middle component. So this times this is -8 minus this times this would be -6. So minus 6 is going to be 6 plus 6. So -8 plus 6 is -2. So it's going to be -2 here. And then this middle component, there's always a negative sign here. You're gonna flip it. So if we got -2, the middle component is really +2. Okay, now we're going to do the same stuff for K. We're going to do the determinant of these guys. So we'll get -2 times 3 is 6. 6 minus 0 times 2 is 0, so this is going to be 6. So that is how you do the cross product. So the cross product gives us a vector. Thinking about it graphically, what this does, so we have these two vectors A and B. The cross product spits out a vector that's exactly 90 degrees from these guys. It's like a new, it goes into like a new plane, a new dimension. It's orthogonal to both of these. So it spits out a new vector. This is A cross B. And then what we'll learn is that the magnitude of this vector corresponds to the area of the parallelogram that these two vectors create. So if you take the magnitude of A cross B, it's equal to the area of that parallelogram. So that idea will be useful later. Okay, now we're talking about what is like a vector, what is a scalar, what makes sense and what doesn't make sense. Okay, so when you do the dot product, that spits out a number. So A dotted with a number doesn't make sense because A has to be dotted with a vector. This would have to be a vector. The result of this would have to be a vector for A dot to make sense. So this doesn't make sense. Because you can't do A dot a scalar, you have to do the vector A dotted with another vector. Okay, here we have A, which is a scalar, being scalar multiplied into what should be a vector. But this is A dot. So that's fine. Scalar multiplication is fine because it's still just a number multiplied to. So B dot C is going to give you a scalar, and we have a scalar times a scalar is just a scalar. So like this would spit out the number 5, and then this is just saying 5 times, and then this would be 5. Wait, what? But b.c is a scalar. Oh, and then this is a vector A. Okay. So A is not a scalar. A is a vector, as it states. So like what you would get, it would be b.c would give you some number like 5, and then you could just rearrange this. It would be 5 being scalar multiplied into the vector A. Okay, so that's kind of, that makes sense. Okay, so b cross c is going to give you a vector, and then A cross that is also going to give you a vector. Okay, so this is a vector, we gotta remember. So we have b cross c, and we have a vector here. And they're being multiplied, but I don't see a dot. So we have a vector, and then nothing, and then a vector. So I'm gonna say this doesn't make sense? Okay, if there's like a dot here, then that would make sense. Okay, there's the dot. So this produces a vector, and then A dotted with a vector is gonna give you a scalar. Alright, given u cross v is equal to this, find u minus 3v cross u plus 5v. Okay, so this is like the distribution rule. So u minus 3v cross u plus 5v. Okay, so we're going to do this one like distribution. So we're going to go u into u, so it's going to be u cross u. Okay, and then we're going to do u cross 5v. So it's going to, we're going to keep the scalar on the outside, so we'll do plus 5, and then it's a u cross v. And then here we're going to do minus 3, and then v cross u. And then we'll get minus 3 times 5 is minus 15 v cross v. Okay, so we need to know is u cross u and v cross v are both equal to 0. So those are going to go away. And then we're going to use another property. These terms can't combine because these are backwards, but we can make them the same by doing u cross v is the same as negative v cross u. So what we can do is flip them, but we have to put a negative sign in the front. So this will be negative 5 v cross, actually what we want to get to is u cross v, because that's what we're given at the beginning. So let's make this one plus 3 u cross v. We still have 5 u cross v here. So this will give us 8 u cross v, and we know what u cross v is, it's 0, negative 3, 1. So we get 0, negative 24, 8. So we get 0, negative 24, 8. Now for the next one. Alright, let A be that, and let B be that. Figure out this. Okay, so maybe we do A minus B, A plus B, and then these are actually crossed. So we get A cross A plus A cross B plus B cross A. Actually, just going negative A cross A minus B cross A minus B cross B. Okay, again, we can ignore these guys and then flip this. So it would be 2 A cross B. So we'll just do that. So do I, J, K, number 2, negative 7, negative 5, 6, 37. So we'll focus on this quadrant first. So we'll get, this times this is negative 49 minus negative 15, so it's plus 15. So we have negative 49 plus 15 is negative 34. So our first component is negative 34. Remember, for the middle component, we're going to negate it, and we're going to focus on these numbers. So we get 2 times 7 is 14, minus negative 30, so plus 30, so this is 34. So we negative 34 again, okay? And now we'll focus on these components, so it'll be 6 minus negative 42, so plus 42. So that is 48. So we're going to take this and multiply it by 2 to get our answer. So it'll be negative 68, negative 68, and 80, 96. Negative 68, negative 68, and 96. The middle term is great. This and this. So we'll get 14 minus 30, 44. So this is negative 44, maybe it's negative 88. Okay, that's right. Okay, a bunch of this stuff. Okay, let's do it. So do you cross these, we go I, J, K, negative 7 to negative 4, 1, negative 3, 2. Okay, so we'll do 2 times 2 is 4, minus this times this is going to be 12. So that's our first component. We're going to do negative 7 times 2 is negative 14. And we'll do negative 7 for negative 14, minus negative 4, so plus 4. For this one, it's going to be 21 minus 2. So it gives you negative 8. This is going to be negative 10, so it's going to be plus 10. This will give you 19. So negative 8, 7, 2. Okay, what am I doing here? Negative 8, 10, 2. Okay, and then this is just going to be this guy but negated. U cross U is U0. Right? Oh, 0, 0, 0. Okay, I'll do negative 2 into this one, so this vector. Negative 16, negative 16. 38, negative 38. Okay, U cross 2V, I think it's going to be the same thing. Okay, this to that. Okay, that's going to be U cross V plus V cross V, which is 0, so it's just U cross V. This. Okay, what is this? Find two unit vectors orthogonal to both U and V, given the exact. Okay, so find two unit vectors orthogonal to this. Okay, that's easy. To find an orthogonal vector to U and V, you have to do the cross product. It will spit out an orthogonal vector. So we're going to do the cross product of U and V. So we'll do I, J, K to U, which is 3, 1, negative 2, K, which is, or V, which is 0, 2, 9. Alright, so let's get to it. So it'll be 9 plus 2. Minus 2. It's going to be negative 27 minus 0. And negate this term. And now it's going to be 6 minus 0. So this is what I get, 11, negative 27, 6. So to find a unit vector, we're just going to divide all of these components by the magnitude. So the magnitude is going to be 11 squared plus 27 squared plus 6 squared. Square root of 8, 6. Okay, so that's orthogonal to both of these vectors. So this is one unit vector. To get the other unit vector, we can just flip this. Square 11 for the square root of 886. This is negative 27. This is 6. And I'll make this a negative 6. Okay. first one's going to be 9 plus 4. 2 times 2 is 4. 9 times 4, so this is 13. That's going to change the bottom. Let's check on the calculator. Yeah, 9 through 4, that's right. This coordinate. Oh, that's right. I flip all coordinates over. So we found our orthogonal vector. Just flipping this. Okay, I guess flipping z isn't gonna. It's gonna spit you out like down here. You want it to spit out, so it has to be like a reflection of this vector. So you negate all coordinates. Positive. I guess that's true. Okay. Okay, find the area of a triangle PQR with point PQR. So if P, Q, and R. Okay, to do this one, we are going to realize that the triangle we want is exactly half of this parallelogram. So we're gonna take PQ from the vector, we're gonna cross it with the vector PR, and then we'll take the magnitude of that and cut it in half, because the magnitude of this cross product is gonna give us this whole area. We should have to cut the area in half. So that's what we'll do. So first we'll find PQ, so it's going to be Q minus P. So it's going to be 5 minus 6 is 11, negative 6 minus 6. So it's negative 6 plus 6 is 0. Negative 6 minus 6, and negative 6 plus 6 is 0. And then negative 6 minus 4 is going to be negative 10. So this is our first vector, PQ. We'll find the vector PR. So it's going to be R minus P. So negative 5 minus 6 is going to be 1. 2 plus 6 is 8. 2 minus 4 is negative 2. 6. 2 plus 6 is negative. Alright. Okay, now we're trying to do the cross product of this. We'll go I, J, K. 11, 0, negative 10. 1, 8, negative 2. Oh, I guess changing the order of these vectors causes the flip of all the signs in the last one. So that's how you get two different orthogonal vectors. You flip the places of the vectors in the cross product. But that's fine, the magnitude is going to be the same either way. So we'll do 0 times negative 2 is 0, minus 80, so it's going to be 80. I'm going to do negative 22, minus 10, so plus 10, so that is going to be negative 12, that's going to turn into positive 12. And then we have 88 minus 0 is 88. Okay, so let's find the magnitude of this, and we'll cut it in half. So 80 squared plus 12 squared plus 88 squared. Okay, so I get 4, 8, 9, 30, so if we cut it in half, we get 2 squared root of 8, 9, 30. We find the area of the parallelogram. So now we're just gonna do the same thing we just did, but not divide by 2. So we'll do q minus p, so pq, pr, okay, so q minus p, it's going to be negative 1, negative 1 plus 2 is 1, 1 plus 6 is 7, 1 plus 3 is 4. This is going to be negative 2 plus 2 is 0, negative 1 plus 6 is 5, negative 4 plus 3 is negative 1. Okay, so now we'll do cross product for ijk. So we'll get negative 7 minus 20. We're going to get negative 1 minus 0. And then we'll get 5 minus 0. So we have 7, 1, 5. So take the magnitude of that. Square of 7.5. Find the volume of the parallelepiped determined by the vectors. Okay, this one's a little trickier. So parallelepiped looks like this, where we have the vector A, B, and C. And to get the equation of this, we're going to do, or to get the volume of this shape, we're going to take the area of this base. So to get the volume, we're going to take the base, we're going to multiply it by specifically this height right here, from here to here. So it's not, we're going to have to do some work to figure out what this height is. So it's going to be base times that height. Okay, so we know to get the base, that's going to be the cross product of A and B. So to get the base, we're going to do A crossed with B. That gives us the magnitude of that. It's going to give us the area of this base. So now we're going to multiply it by the height. So the height is going to be this guy right here, red. So to get the height, what we're going to do is we're going to take our cross product vector here, take the cross product of A and B, which is an orthogonal vector going straight up. And if we project C onto this vector, then that's going to give us our height. The projection, if we think about shining like a flashlight this way, the projection of this vector C onto our blue vector is going to be the exact height. So let's draw that like this. We'll go get this vector C, and then we'll have our blue vector, which is going to be A cross B. And let's try this out better. We have this new orthogonal vector A cross B, and the projection is our height h. So this is going to be h. So I'm going to call A cross B the vector n. So this is the vector n. And we're going to do, to get the projection vector, we'll do what we did in the previous assignment. This is going to be, if this is the magnitude of C, then this side length is the magnitude of C times the cosine of theta, where theta is this angle. If you want to get the angle between two vectors, we're going to use the formula cosine inverse, and then it's going to be C dotted with n, magnitude of C magnitude of n. So we see that these cancel, and the magnitudes of c cancel. So the length, the length of this projection vector is this stuff remaining in here. C dot n over the magnitude of n is the length of this vector. So I'll put that in. And then we're going to do what we did before. We're going to think about scaling the unit vector of n. We're going to take this tiny vector and then we're going to scale it by the magnitude, this distance here. So we're going to take this distance and scale it into the unit vector n hat. So I'll start putting arrows on things here. So we have the vector c dotted with the vector n divided by the magnitude of n. So this is the scalar component of the projection. And then we'll have n over the magnitude of n. So there's our projection formula. It's c dotted with n over the magnitude of n squared into this vector n. So this is our height. So we're doing base times this, where n is the cross product. So we can plug that into here, except now I'm going to write n back into a cross b. So we'll go height is equal to c dotted with n is a cross b divided by the magnitude of a cross b squared. Then we have the magnitude of a cross b. Okay, so we're replacing the n's with a cross b. And we're going to multiply this by the base, which we figured to be the magnitude of a cross b. So we're going to multiply now by further a cross b. So again, this is our height, and this is the base, the area of that parallelogram at the bottom. And you'll see that when you multiply, we have two of these magnitudes of the cross product on top and two of them on the bottom, so they're going to cancel each other. And we get the formula for the parallelepiped. Jesus, I butchered that. I'm not even going to try and spell that. The volume is going to be c dot a cross b. So this is all you have to remember. So it's using some projections to get the height, and then you already know that the base is going to be cross product of a and b. So let's go back and computing this. First we're going to do the cross product of a and b. So we'll go I, j, k. A is 5 to -1. B is 0 to 3. So we're going to get 2 times 3, which is 6, minus, it's going to be plus 2, so that's 8. We're going to get negative. We're going to get 15 minus 0, so just negative 15. And then we're going to get 10 minus 0, which is just 10. Okay, so it's this, and now dotted with c. So dotted with, now c is going to be the vector 2, 5, 1. So we get 16 minus, what is that, 50 plus 25, 75, plus 10. So that's going to give us 16 minus 75 plus 10, negative 49. So we'll just take the absolute value of that, 49. Okay, that's right. Okay, so now we're going to do torque. Yeah, that's right, torque. Okay, so torque is the, again, like the area of these two vectors. We're gonna do the cross product. We have this force vector, and then we also have this distance vector. And then the area that they create here, this is the torque. So to get the torque, then we're going to do the cross product of the force vector and the distance vector. So yeah, that's all we have to do for this one. So we just have to figure out the force vector and the distance vector are. Force vector is just a straight up 7. So that's nice. Force vector is, it goes 0 in x, 7 up in y. Distance vector goes, it's going to be 0.1, the magnitude times the x component is going to be sine of 34, and the y component is going to be cosine of 34. Since our thing is like this, and we're given this angle, then the x component here is sine, and the y component is cosine. Alright, so we're just going to do the dot product. No, we're going to do the cross product now. Okay, and then to do the cross product. Okay, wait. There's another formula. You can think about the distance here. See, like, you want to do the cross product, but you see you're in 2D, and the cross product in 2D is kind of annoying because you've got to throw in some invisible zeros here for the z. Another way to do it is we remember that torque is this area. The torque is the area of this parallelogram. And to get the area of the parallelogram, you can, instead of doing cross product, we can simply do base times this height. So the base, let's call this vector f and this vector d. The base is going to be the magnitude of d and then we see that the height is going to be f sine theta. The magnitude of f sine of theta. So that's what this height is. If this is the magnitude of f, then this distance here is f sine of theta. So then base times height is going to be f d sine of theta. So this is like the formula you'll see in physics, actually, for torque, which is equivalent to doing the cross product. It's giving us the area of this parallelogram. That's what it's doing. So that's torque. So this is a better way to do it when things are in 2D. Find the magnitude of f, find the magnitude of d, and then multiply by the sine of the angle. So let's do that. Magnitude of f is going to be the square root of... actually, it's going to be some nasty decimal. Oh, okay, no, this one's going to be... Its magnitude of f is 7, we know that. Times the magnitude of the distance is not this triangle. Oh no, actually it tells us now. 0.1. 0.1. Distance is 0.1. See, this is why it's really nice. Now sine of 34. So 7 times 0.1 times the sine of 34. I get 0.39. Alright, there we go. That's it. That is all of torque in 2.4. All of cross product, I should say. So in the next one, I think we're doing equations of planes and lines in space. So, alright, that's it. Adios.